welcome everybody. I hope you all are having a wonderful weekend or blessed day wherever you are, whenever you are watching this. Uh, it's going to be a rather shorter one as it got a limited amount of time, but we'll make it short but sweet. And sweet is the taste of the water that you are looking at in a frozen state in that ice cube on screen. That is structured water, easy water. You can see the exclusion zones, what EZ water stands for. And these are lines of bubbles. They're fields of bubble, field forces, keeping those bubbles structured in those parallel concentric rings in that ice of the ionic gold silver water that I make out of the monoatomics. And it's quite something. And I realized the other day when I was watching the two AIs discussion, JD's AI discussion channel video on Ken Wheeler of the toroids, and then clicked in Bob Greenier's bagel coil, the coil within a coil within a coil, the field within a field within a field, and that's actually what I use when I was making a lot of the ormus that I do. And well, is that why I have these toroidal field lines structured and, I guess, imprinted into the memory of the water and this ice, potentially, and the electromagnetic chemistry of the torsion field is another very interesting aspect and principle that I got out of thinking on this and reflecting on what we're looking at, as well as other experiments that I've done with the coils in electrolysis, in electrochemistry, and the fact that in my anodes and cathodes, when I have the triple toroid solenoids that create electromagnetic fields or electromagnet force, when you put current through it, that is actually affecting the outcome of the actual chemistry itself, the electrical chemical reactions, and explains why on some sides it's red and other sides it's blue, because oxygen magnetic, hydrogen not, and that depending where the field is, that it will alternate and have different chemical reactions going on. Very interesting here. This is a close-up of monoatomic silver, as well as some diatomic oxidized silver at the bottom there. You can see the blue, but that I was doing the first rinse. I had poured all the water out of the top. When you look at something like this, right? So you just have the ormus at the bottom and then all the water at the top. And then you pour this water out when you're rinsing it to get the salt out, and you refill it with fresh water, and then it gets all mixed up like that. And that's what we're looking at right here. But I did it during a full moon. I always rinse the silver during full moons, and sure enough, it almost goes neon. Like, yes, there's a bright LED light behind it, but the fact that it goes so bright yellowy green, very fascinating. And then it settles and it goes back to being white. It's very anomalous. Showing some pictures of it there. Here we have the pink crystalline state of copper up on screen, and that is the state that Sir Isaac Newton stated metals are in a crystal form and can be transmutated from one physical element into another. That right there is actually the shine, the refraction of copper crystals reflecting the light. And there's actual crystals on that. Here we have some zinc or copper nanotubes forming. Yeah, it's a zinc nanotubes forming off of the zinc anode on the inside. They grow, they're self-arranging, and they create the nanotubes. Very, very peculiar stuff on how they self-organize and make these different structures. It's almost as if intelligent, but not quite. But I bring it up and show it because of some of the other AI discussion videos I've been listening to. And here we have another example of these nanotubes. This is triple copper 2 solenoid coils. And growing off of it, not blue, but green and some almost black and brown. And I guess, yeah, green nanotubes of copper. Copper nanotubes self-arranging as if they're alive. And here we have the black nano coating, another color of Sir Isaac Newton's transmutational metals. Here we have that's silver. This is gold monoatomics. And then the spiraling, self-organization of the spiral. And is it this plasma just, is it conscious? Is the direction, is it alive? Regardless, it's doing it all on its own. And what is the force and direction behind this structure and self-organization? Here we have more monoatomic gold and some monoatomic gold and silver at the top there. No, it did it through its own. It will always, so anytime I put or add additional water into one of the jars or containers, it's all of a sudden just goes up in from a cloud, and then it goes and creates that spiral as it self-organizes into a new homeostasis within it. It's very interesting stuff. Yeah, and exactly, contraption. 100% that I've been thinking the same thing. Is it reflective? Does it go clockwise in the north and counterclockwise in the south, and vice versa? Very, very interesting. I'm gonna start paying attention to that and documenting it. Here we got gold nano crystals right there. Very fascinating stuff these crystals were. Hey, shout out that Dazzle, good to see you. Interesting. I will check it out, my friend. Okay, so the relevance of it and the videos I wanted to play quickly. I guess first we'll finish this presentation of the pictures. There you can see another nanotube growing off the gold. You got the blue and orange, the pure white. Some more of the nano structures, the tubes, and different self-organization of structures that form. Here we have red and pink state aluminum, copper, silver, and copper. You can see the red there, the oxidized, and the yellow, with the thin line of white separating the green and the yellow. How the chemistry and the different oxidization and hydride formations happen. It's very strange. Here we got pink and red state iron and copper, and also it formed a white nanotube that had gone from the top to the bottom, but then it broke when I hit the bottle there. It jiggled and it broke, but it had grown and remained there for about a solid year. Here we have an exclusion zone right at the top. Always happens. Very fascinating. Oops. Some of the pink and white red state. And it's all copper, right? It's like, how does it change all of these different colors? Very fascinating. Here we got another spiral of the self-organization, and 2 spirals of the self-organization. The oxygen trapped on the anode triple solenoid because of its magnetic field. So here you can see that's one of these is this guy right there. Probably like that one. That one is what you're looking at right here. And then this guy, it's like one of those sort of things. One of those. There we go. One of them. Different colors of the Ormus. Shout out Stephen A. Smash that like button, baby. Yes, please. Nanotube growth remind me how lightning strike. Yeah, it is kind of similar and it's interesting that way. Good observation. I like that. Okay, so back to now we're going to play a little bit of one of the videos before I have to run of the 2 AIs discussing this one, the fossil fuel myth. What's it actually made of? I don't think it's dinosaurs. Neither do the AIs. Let me know if you can hear.
The evidence and all the head-scratching implications.
Happy to be here, ready to get those brain cells firing.
All right, let's start with the basics, the kind of textbook narrative that most of us learned. You know, oil and gas come from decomposed organic matter, ancient plants, dinosaurs, that sort of thing.
Yeah.
The classic fossil fuel story.
Right, that's the biogenic theory. And it's been the dominant explanation for how hydrocarbons form for quite a while now.
Okay, but then there's this other theory, the abiotic theory. And it suggests hydrocarbons.
All right, so for those unaware, there is a second scientific theory of how hydrocarbons, aka oil and gasoline, which is refined from the oil, is produced, and that fossil fuels aren't made by fossils, and that the Soviets, during the Russians from the Soviet times, the Soviet Academy of Sciences, actually published research and papers saying that it was abiotic, and that explains why we're finding hydrocarbons on Io, on Mars, on many of the planets and moons of our solar system. And it's most likely actually a renewable resource. Just it's very slow in renewing, but there's a lot of evidence from it. Good to see you, Mountain Grizzly. Welcome, welcome. So yeah, abiotic process of oil and gas as opposed to the fossil fuel myth. And here, this is the second of the 2 videos they've done on it. The first one was really good. I think they cover a lot of this stuff in this one. We'll see.
The building blocks of oil and gas can form in a totally different way from inorganic materials deep within the Earth's mantle. And this happens completely independent of any biological processes.
Yeah.
So no ancient ferns or T-Rex bones required.
Nope.
But hold on, if there's no organic matter down there, how in the world could oil and gas form in the mantle?
That's where things get really interesting. The Earth's mantle, it's basically like a giant pressure cooker.
Right.
The temperatures and pressures down there are so extreme that they can trigger all sorts of chemical reactions.
Okay, so like extreme chemistry.
Yeah, reactions that would be impossible at the surface. And one of these reactions, it's called the Fischer-Tropsch process. Basically, it's a way of creating hydrocarbons from inorganic materials like carbon dioxide and hydrogen, stuff that's actually super abundant in the Earth's interior.
Got it. So instead of decaying plants and animals, we've got carbon dioxide and hydrogen getting cooked up into hydrocarbons under intense pressure. It's almost like the Earth has its own hydrocarbon factory down there.
Exactly. Just a theoretical possibility either. Scientists have been able to replicate these extreme mantle conditions in the lab using something called a diamond anvil cell.
It's pretty cool, actually. They basically take tiny samples of material and squeeze them between 2 diamonds. I mean, we're talking pressures millions of times higher than atmospheric pressure. And then to really crank up the heat, they zap them with lasers to mimic the temperatures found in the mantle. So they're basically recreating a tiny slice of the Earth's mantle in the lab. And are they actually creating hydrocarbons from scratch in these diamond ovens?
Yes. And the experiments have shown that forming hydrocarbons from metal.
What? So right there, saying we humans have reproduced hydrocarbons artificially by squeezing them between 2 diamonds and heating them with lasers. No biotic material needed. There's something very, very interesting. Let's continue here.
Methane, which is the simplest hydrocarbon under these mantle conditions, it's not only possible, it's actually thermodynamically favorable.
Thermodynamically favorable. So you're saying the laws of physics are kind of rooting for this to happen.
Exactly. It's like the universe is
sound
saying,
like that
hey,
a
this
little bit.
abiotic hydrocarbon thing, it makes sense.
Okay, that is mind-blowing. But I have to ask, are there any real-world observations that back this up? Does the abiotic theory explain things that the traditional biogenic theory can't?
Oh, absolutely. There are quite a few intriguing examples that really make you think. For instance, we're finding oil and gas deposits in places where they really shouldn't be, according to the biogenic theory. We're talking about areas with little or no source rock.
Source rock, that's the organic rich sedimentary rock that's supposed to be like the cradle of oil, right?
That's right. But we're finding oil in places where that kind of rock is basically absent.
So we're finding oil where it shouldn't be. That definitely throws a wrench into the textbook narrative.
It does. And the abiotic theory offers a potential explanation. What if these hydrocarbons aren't forming in these unlikely places, but are actually migrating upwards from the mantle? Traveling along deep faults and fractures in the Earth's crust.
It was like an underground pipeline from the Earth's hydrocarbon factory.
Exactly. It's like a hidden network delivering oil and gas to places that the traditional theory can't explain. And it's not just about the location of these deposits. There's also this phenomenon of replenishing oil fields. There have been cases where oil fields that were thought to be completely depleted have mysteriously started producing again.
Wait, so you're saying some oil fields are basically refilling themselves?
And that is what the Soviets found, and it was in the Aral Sea area, I believe, and the Chechnya area, I believe, where they were noticing that the oil, what were spent used oil fields that they had pumped out and drained were replenishing, And that is what they led them to investigate and look into it and come up with the thesis of abiotic oil.
Sounds almost too good to be true.
I know, right? But it's a phenomenon that's been observed in multiple locations around the world. And the abiotic theory, it offers a really compelling explanation. If hydrocarbons are continuously forming and migrating upwards from the mantle, well, it's totally possible that they're replenishing these reservoirs over time.
That's incredible. Okay, I'm starting to see why this theory is.
Can you invest in American real estate if you're a foreigner?
Stupid ads. One day I'll get premium.
So captivating. It's like a whole new way of looking at our planet and its resources.
It definitely challenges our assumptions.
Now, I've heard about this ambitious drilling project in Sweden, the Siljan Ring project. Wasn't that supposed to prove or disprove the abiotic theory once and for all? What happened there? Did they strike abiotic oil?
The Siljan Ring project, that was a really fascinating attempt to test the abiotic theory in a place where the traditional biogenic theory wouldn't hold up at all. They decided to drill into a massive impact crater in Sweden. And this crater was filled with granite.
Granite. That's an igneous rock, right? The kind that forms from
Granite.
cooled lava. Not exactly the kind of rock you'd normally associate with fossil fuels.
Exactly. They were basically saying, if we find oil here, it has to be abiotic because there's no source rock in sight. It was a bold move.
So what did they find? Did they hit the abiotic oil jackpot?
The results, well, they were intriguing, to say the least. They did find hydrocarbons, maybe not in huge commercially viable quantities, but enough to raise some eyebrows. And the hydrocarbons they found had a chemical signature that was actually more consistent with an abiotic origin.
So they found oil in a giant granite crater. That's pretty strong evidence in favor of the abiotic theory, wouldn't you say?
It definitely adds fuel to the fire. But the Siljan Ring project also yielded some other really interesting findings. They discovered magnetite, which is a type of iron oxide that was enriched with iridium.
Iridium, isn't that pretty rare on Earth's surface?
It is, but it's more common in meteorites, which is pretty interesting because the presence of iridium in the Siljan Ring magnetite suggests a possible deep origin for this material. Remember, the impact that created the Siljan Ring crater would have fractured the Earth's crust. And that could have created pathways for materials from the mantle, including hydrocarbons and associated minerals, to migrate upwards.
So the impact that created the crater might have also opened up a pathway for abiotic oil to reach shallower depths. Talk about a cosmic coincidence. But speaking of things traveling upwards from the mantle, what about helium? Doesn't the presence of helium in many oil and gas fields also lend support to the abiotic theory?
Absolutely. Helium is kind of a unique element. It's chemically inert, which means it doesn't react with anything. It's like the lone wolf of the periodic table.
I like that. The lone wolf element. So how did this lone wolf end up in oil and gas deposits? It seems out of place if oil is just decomposed organic matter.
Exactly. The biogenic theory has a really hard
Helium. And that could be also indicating potential LENR cold fusion reactions going on there as well.
time explaining why helium would be hanging out with oil and gas. But the abiotic theory has a nice, neat explanation. Helium, just like hydrocarbons, is thought to originate in the Earth's mantle, and it migrates upwards through the crust.
So finding helium in oil and gas fields is like finding a fingerprint that points to a deep abiotic origin for both the helium and the hydrocarbons, like they were buddies on a road trip from the Earth's interior.
That's a great analogy. The association of helium with hydrocarbons in many oil and gas fields, it's a really compelling piece of evidence, and it's hard to explain with the traditional biogenic theory.
Okay, I'm really starting to see how the pieces of this abiotic puzzle fit together. And it's making me question everything I thought I knew about where oil comes from.
It's a real game changer.
The abiotic theory kind of throws a curveball at the traditional explanation of oil formation, especially with the whole helium thing.
Like finding a penguin in the Sahara Desert doesn't quite fit the usual picture.
Yeah, exactly. And there's another piece of this puzzle that's just as mind-boggling. This whole idea of oil being found in places where it logically shouldn't exist if we're sticking to the old textbook narrative. Remember how we touched on that?
Absolutely. The case of the missing source rock, right?
Bingo. And one of the most striking examples of this is the White Tiger oil field over in Vietnam.
Ah, yes, the White Tiger field. A poster child for the abiotic theory, if you ask me.
Okay, I'm all ears. Lay it on me. What's so special about this particular oil field?
Well, it's churning out high-quality crude oil, just like you'd expect from a regular organic matter-derived oil field.
Makes sense so far. So what's the catch?
The catch is the source rock, the rock layer where this oil is supposedly coming from. It's basalt.
Basalt. Now, correct me if I'm wrong, but isn't basalt an igneous rock? Like the kind that forms from cooled lava? That doesn't exactly scream oil reservoir, does it?
You're absolutely right. Basalt is about as far away from your typical organic rich sedimentary source rock as you can get. There's virtually no organic matter in basalt, which is supposed to be the main ingredient for oil, according to the biogenic theory.
So how do those who are still clinging to the traditional explanation, how do they explain oil flowing out of a place like the White Tiger Field? It's like finding a palm tree growing in the Arctic Circle.
Well, they have to get pretty creative with their
So now they've found oil both in granite and basalt, two different igneous formations and chemicals that should not be proven or providing it, yet it's there. Very, very fascinating.
explanations. They might suggest that
Oh yeah, peak oil too, right? They've been claiming peak oil since 1970, yet we keep finding more and producing more and pumping more out.
the oil actually migrated there from some distant source rock, somehow maneuvering through layers of rock that should act like, well, impenetrable barriers.
That sounds like a pretty convoluted explanation. It's like saying the Nile River somehow managed to flow uphill to reach the Mediterranean Sea.
It does make you wonder. And that's where the abiotic theory steps in with a more, shall we say, elegant solution. What if the oil in the White Tiger Field formed right there in the mantle from inorganic materials and then simply seeped up through cracks in the basalt?
So the oil took a shortcut.
Precisely. And the White Tiger Field isn't an isolated incident. There's a growing body of evidence suggesting hydrocarbons can form and migrate through igneous and metamorphic rocks, rocks that the traditional theory never even considered as players in the oil game.
This is absolutely revolutionizing the way I think about oil. It's like discovering that water doesn't actually come from rain, but springs up from the Earth's core.
It's a paradigm shift for sure. The White Tiger Field and others like it are forcing us to re-examine everything we thought we knew about how oil forms and where it can be found.
Okay, so we've got oil forming in rocks that shouldn't have oil, and we've got oil fields magically refilling themselves. The abiotic theory certainly seems to explain some things that the biogenic theory struggles with.
It's definitely
And they haven't even mentioned the fact that they're finding these quote unquote fossil fuels that are not made of fossils, obviously, that they're finding these petroleum products on other planets of our solar system and other moons of our solar system as well. So, yeah, that could explain why it's there without life.
a compelling argument. Let's take a look at the Kola Super Deep Borehole.
Okay, the Kola Super Deep Borehole.
It's one of the deepest holes ever drilled into the Earth, reaching over 7 miles deep.
That's got to be some kind of record.
It is. And what's remarkable is that they found methane,
Okay,
a type of hydrocarbon,
right.
at depths where, according to the traditional biogenic theory, there should be virtually none.
So they dug deeper than dinosaurs and still found oil.
Yes.
That's a big challenge to the conventional wisdom, isn't it?
It certainly is.
Yeah.
It suggests that the methane they found is coming from a source far deeper than any fossil fuels, and this finding isn't an isolated incident.
Right.
There are other examples around the world where hydrocarbons are found in unexpected places,
Mhm.
challenging the traditional depth limits of oil formation.
Okay, I'm starting to see why this theory is causing a stir. But how do these hydrocarbons formed deep within the Earth make their way to the surface where we find them?
That's a great question, and this is where the concept of upward migration comes in.
Upward migration.
Think of it like a giant slow-motion conveyor belt moving hydrocarbons from the Earth's mantle towards the crust.
Okay.
This migration is driven by pressure gradients and geological processes like faulting and fracturing, creating pathways for hydrocarbons to travel upwards.
So these hydrocarbons are constantly on the move, slowly working their way up from the depths.
Yes.
It's like a hidden plumbing system within the Earth.
Exactly. And one of the key principles explaining this upward migration is something called Kudryavtsev's rule.
Kudryavtsev's rule sounds a bit technical. Break it down for me.
It's actually a pretty simple concept. concept. Imagine a column of rock extending from the Earth's surface down to the mantle.
Okay.
Kudryavtsev's rule states that the density of hydrocarbons decreases as you move upwards through this column.
Okay, so lighter hydrocarbons tend to be found higher up, while heavier ones stay deeper down.
Precisely. And this density difference is what drives the upward migration.
Whoa.
The lighter hydrocarbons like methane are more buoyant and tend to rise towards the surface, while the heavier ones like oil might take a much longer journey.
This is starting to paint a very different picture of how oil forms and accumulates. But is there more to the story than just the location and movement of hydrocarbons?
There is the composition of these hydrocarbons also tells a fascinating tale, and this is where we delve into the realm of chemical and isotopic anomalies.
Anomaly sounds intriguing. Tell me more.
Well, some hydrocarbon deposits, especially those thought to have an abiogenic origin, contain unusual element and isotopic signatures.
Okay.
For example, high levels of helium and argon-40 have been found in certain oil and gas fields.
Helium and argon, aren't those typically associated with noble gases, not hydrocarbons?
Yes, and that's what makes their presence in these deposits so intriguing. Helium and argon-40 are primarily found in the Earth's mantle, not in the organic matter that's supposed to form oil, according to the traditional theory.
So it's like finding a fingerprint that points to a completely different origin story.
Exactly. These elements are like chemical messengers from the deep, suggesting that the hydrocarbons they're associated with might have originated in the Earth's mantle.
That's fascinating. Are there any other chemical clues that support the abiogenic theory?
There is another intriguing clue hidden within the carbon itself.
Okay.
The ratio of carbon isotopes, specifically carbon-12 and carbon-13, can vary significantly in different hydrocarbon deposits. And some methane deposits, particularly those found in deep ancient rock formations, have isotopic signatures that are strikingly different from what you'd expect from a biogenic origin.
Okay, so the type of carbon in these deep methane deposits doesn't match the carbon you'd typically find in decomposed organic matter.
That's right. It's another piece of the puzzle that points toward an abiogenic origin for these hydrocarbons.
This is all starting to make a lot of sense, but I'm curious, are there any specific geological formations that provide evidence for abiogenic hydrocarbons?
There are, and these formations are often linked to dramatic geological events, which provide even more support for the abiogenic theory.
What kind of events are we talking about here?
Think meteor impacts
Okay.
and volcanic activity. These events can create pathways for deep fluids, including hydrocarbons, to rise towards the surface.
Okay, so these cataclysmic events are like opening a pressure valve,
Yeah,
allowing hydrocarbons from deep within the earth to escape.
exactly.
Wild. All these examples, lab experiments, deep drilling discoveries,
Yeah.
chemical anomalies, and oil found in unexpected geological formations are painting a very convincing picture. It seems like the evidence for abiogenic hydrocarbons is pretty strong.
The evidence is indeed compelling. It's challenging long-held assumptions and opening up exciting new possibilities.
It's mind-blowing to think that our planet might be generating hydrocarbons deep within its core, constantly replenishing its energy reserves.
It is a profound concept, and it leads us to another fascinating aspect of the abiogenic theory, the potential for a deep hot biosphere.
Now that sounds like something straight out of science fiction.
It might sound like science fiction.
Yeah.
But the evidence is mounting. Okay, so imagine a hidden world, miles beneath our feet, teeming with microscopic life, no sunlight, intense pressure. But these extremophiles, they thrive on chemicals and heat, potentially even feasting on abiotic hydrocarbons.
Wait, you're telling me there's life down there in the Earth's mantle? What are they, like fire demons?
Not demons, but extremophiles, tiny organisms that laugh in the face of extreme environments. Think about the hydrothermal vents on the ocean floor, thriving on chemicals from volcanic activity. They show us that life can exist in the most unexpected places.
All right. So we've got hydrocarbons forming deep within the Earth, potentially feeding a hidden biosphere. So while we humans are up here enjoying the sunshine,
Right.
there's a whole other world below us powered by the Earth's internal heat and chemicals.
Exactly. And this deep hot biosphere might be far more expensive than we realize. It could extend for miles beneath the continents and oceans, representing a vast hidden biosphere,
That's crazy.
potentially exceeding the biomass of all surface life.
Wow, that's incredible. A whole hidden world teeming with life.
Right.
A world we're only just beginning to glimpse.
And the implications of this are profound. It challenges our understanding of where life can exist
Right.
and what it needs to survive.
So there, it's like, well, if it can survive in the mantle, it could survive in Venus or probably Mars or Io, the moon of Jupiter, or who knows where, right? It's very interesting. Very interesting.
Hmm.
It also raises fascinating questions about the interconnectedness of Earth's systems.
Yeah.
If hydrocarbons are constantly being generated and consumed within this deep, hot biosphere, it means there's a dynamic exchange of energy and materials happening deep within our planet.
It's like a giant hidden engine driving the processes we observe on the surface.
Precisely. And the
Good call, Mountain Grizzly. Like, I had not really thought of that. Like, this, it really does. The male AI voice does sound like Dutch. Right? Yeah, that's actually two AIs talking right there. It's pretty wild stuff. But yeah, I'm running out of time here, so play a little bit more of it, and then I've got to go. But thank you all for being here, and it's very interesting information.
implications for energy resources are equally significant if hydrocarbons are not just the product of ancient buried biomass,
Right.
but are constantly being generated by geological processes.
Yeah.
It means our planet's energy potential might be far greater than we ever imagined.
Okay, let's pause for a moment and let that sink in. We're talking about a potential paradigm shift in our understanding of life energy. And the Earth itself, the abiogenic theory, coupled with the deep hot biosphere, paints a picture of a dynamic, interconnected planet with resources that might be far more abundant and renewable than we ever thought possible.
It's a captivating and challenging perspective,
Yeah,
one that's forcing scientists to rethink long held assumptions and explore new frontiers.
it is.
And while the debate continues, the evidence supporting abiogenic hydrocarbons and the deep hot biosphere is growing.
So where do we go from here? What are the next steps in unraveling this scientific mystery?
Continued research, deeper drilling explorations, advanced analytical techniques, and an open mind. We need to investigate more sites like the Kola super deep borehole and the Siljan Ring. We need to study the microorganisms thriving in these extreme environments, unlocking the secrets of their metabolism and survival mechanisms. And we need to develop new technologies to probe the depths of our planet, unveiling the mysteries of the deep hot biosphere and the potential for abiogenic hydrocarbons.
Good to see you,
It's a
Valley.
call to adventure for the scientific community, a quest to understand a hidden world that might hold the key to our planet's past, present, and future.
Indeed. And let's take a little trip beyond our planet. Okay. We found hydrocarbons on other celestial bodies, asteroids, comets, even the moons of Jupiter.
So you're
There we
telling me
go.
that space is full
Now
of
they're-
oil?
Not exactly oil as we know it, but hydrocarbons, the basic building blocks.
Wow, that right? Like, not sure that's we got Dutch Sense and Julia voices basing that AI. That's weird. It's like, have they been listening to just me, or what's going on? And is that why I like it seems so naturally like it's hard to tell that they are AI when you're listening, but right? Oh yeah, right. Don't if you like, do we need Dutch to have a mental breakdown from this, or we'll just let it be? No, I'm just joking. But yeah, I would probably trip the fuck out too. And like, why does it sound and yeah. All right. Well, on that note, I probably should get going and but before I do, we're going to be looking into the elements a lot more going forward and getting into the real aspects of the chemistry and the electrochemistry of it all. And we will be starting with the D block and the transition metals, which I will be here you can see, right, the different blocks as they're put or arranged in modern day, less accurate periodic table compared to that's just 2 of, I believe, 20 or 30 different charts and tables that Walter Russell made of the periodic tables of elements, and that will be me, aka me, myself, and I, Bernie, Bert, and Ernie, will be transferring or demonstrating or plotting out the different blocks and separations of the academic periodic table compared or onto the Walter Russell periodic tables, so that we'll get the best possible picture and connection of how these elements actually form and work, and the cold nuclear harmonic fusion, plasma fusion, field fusion that we're seeing and that nature works with. All right, so on that note, love you all. Thank you for being here, and we will see you on the next one.
You crazy mother. Yeah.
It's just Bernie. Hey, Bernie, just like last week, huh?
Weekend at Bernie's.
Yes, I'm planning on doing it this summer.